right, ladies and gentlemen, so let's go ahead and get started here. Take a look at the answers for numbers 1 and 2 for me, please. 1 and 2. Good. Looking through problems 1 and 2. Please let me know if you've got questions on these guys. Today is going to be really a lot of what we did last class, just tiny tweak. But if you've got questions, we can keep from having more difficulties today. Okay? Yes, ma'am. No, just know that when you get to calculus, that notation is very important. Okay? Anybody else? No? All right, let's take a look at problem number 3. So I'll scooch it up so you can see number 3. Since it didn't ask me what time it would occur at, it's just saying how many hours. You can leave it as like 30.1. It's okay. Viv, are you having troubles with the answers? You sure? You said I heard still not right. All right. Anybody with questions on those? Okay, well, what about your homework? Do you have questions on your homework? Yes, ma'am. Number 12. I was waiting for that. I'm glad it didn't take too long to pop out. Number 12 is kind of a that was mean problem. That was mean. And the reason why I say that is because for number 12, we start off with the fact that his hair is half an inch. Nice little buzz cut there. Hair grows continuously at a rate of 1/4 of an inch per month, but that's not at a percentage rate. That's a flat rate. That's every month he gets another 1/4 inch, and then another 1/4 inch, and then another 1/4 inch. So what we're looking at this here is more along the lines of this equation. Starting off at a half an inch, gaining a 1/4 of an inch each month. And we're trying to figure out the length of his hair after a year. So if this is how much we grow each month, my time is 12, because that's 12 months for a year. So his hair is a total of 3.5 inches. Which is pretty much true. Your hair grows at about a 1/4 inch every month. But it doesn't say like 25%. Imagine how quickly Kendra's hair would grow if it grew by 25% each month. Versus Cameron, 25% each month. Cameron's hair would stay pretty short. Kendra would all of a sudden be dragging on the ground. Connor, I'm sorry. Nope, I'm having blood circulation issues right now, so my brain's not functioning. Very good excuse. Dang good excuse. Okay, other questions from the homework? Yes, sir. Number 8. Okay, when we're talking about half-lives, basically what I do is, you know that the first thing you'll have to find out is what your rate is. So for problem number 8, I start off by saying, since it says the half-life is 3 days, I set that up doing 1/2 is equal e to the r times 3. And I can use this to solve for my rate. I do that by taking the natural log of both sides. That means I now have the natural log of 1/2 is equal to 3r, which means my r is going to be the natural log of 1/2 divided by 3. Make sure we close those parentheses. And so I get my rate to be negative 2.31, or negative 0.231. And then going on with the problem, it then says that, 750 ounces are initially used. So I start off with 750. 100 ounces are remaining, so that's my final amount. We're looking for how many days passed. So setting this up, I'm going to say f of t, which is now 100, is equal to the initial amount times e to what I had before for r, negative 0.231 t. So what would we do to solve that first? Yeah, divide by 750. And if I did that, I would have, what is that? Whatever 10 over 75 is. 0.231. Then what would you do? ln, which would leave me with ln of 10 over 75, I think that's 2 over 15, is equal to negative 0.231 t. So what would we do to finish this? Right, divide. So I'd have that my t is equal to ln of 10 over 75 divided by the negative 0.231. And I can round to write it down into my calculator, but when I write it down, but in my calculator, I'm going to use that actual number. So I'm going to say ln of 10 over 75, make sure we close that parenthesis, divided by that previous answer. And then we get the 8.723. And for this problem, we were measuring it in days. Okay? Yes? If I asked you how many hours? If I asked you what time it happened at? I didn't ask what time it happened at. When you've got a decimal involved. Okay? Does that kind of answer your question about that? You're looking specifically for that word continuous or the idea of a half-life, something that's going to be happening continuously. Anybody else questions on this? You guys look so excited to be here. Can I get someone to shut the door for me, please? Anybody else? Any of these 12 problems? All right, so what we're going to do first is we're going to pick up with where we left off last class. So why don't you pull those notes back out? We're just going to do those last 3 problems. And I actually want you guys to solve these for me. See what you can do about 6, 7, and 8. Okay, go ahead. So, today, we're putting on our grown-up pants. Adulting 101. Oh, the worst part about being an adult. Financial worries, taxes, yes. Yes, I tried to do those last night. I tried, and then my refund was so little, it was easy for me to say. The refund was less than what the software was charging me, so I was like, okay, now. Yes, taxes suck. Compound interest. Compound interest. Basically what this is saying, this is why you don't get involved with the mob. There you go. Bringing the mob into this. You borrow money from the mob. They give you like a crazy interest rate. It's like, okay, 50% each month. So you take out a $1,000 loan from the mob. They come back to break your kneecaps 2 months later. You're owing them $1 million. And probably not that severe. But still. Because what happens with compound interest, and this is what happens on your credit cards. You want to talk about a mob on a smaller level? Credit cards. You buy a $120 pair of shoes because you're like, dude, I'll put this on my credit card. Whatever. Pay the minimum amount, it'll be good. By the time you've paid off an $120 pair of shoes, you probably paid closer to $200. for that pair of shoes. That's how credit cards work. Basically, every month you get, bless you, interest on what you owe. So now you owe more. The month after that, you have to pay interest on the interest that you got the previous month. And it just kind of spirals. It's like a snowball going down a hill. It keeps picking up, keeps picking up. The bigger it gets, the more it picks up. That's the idea of compounding interest. So every single one of you will have to deal with this at some point in time in your life. And the formula for compounding interest is only a tiny bit different from what we were doing last class. Now that formula is, well actually let's start off with last class. Last class we said f of t was equal to a times 1 plus r to the t. Right? That was last class. Today, we're going to adjust that a little bit. We're going to use slightly different notation because when people get out of high school, they want to get as far away from notations that you use in high school as humanly possible. No. I never use math anymore. So they changed up the notation. We have another issue. This formula says it's only going to compound once per time period. But if you're looking at how things work in the real world, your credit card statements, your bank accounts, that happens every month. But the rate they give you is still yearly. So how do we take that into account? So we make a little bit of an adjustment here. First off, we're going to change the letters. Instead of talking about f of t, we're going to be calling this a. A stands for the final amount. That's kind of like saying your f of t. That's your final amount. Does anybody know what P stands for? Yeah. Oh, freaking beautiful. This stands for the principal. And principal is spelled L-E, not A-L, because it's not your pal, the principal. I know, that's the only way I remember it. So we've got this. And so this is replacing, this is your initial amount. And previously we called that our lowercase a. Now, we still have 1 plus. We still have R. R is your interest rate. Usually that will be yearly. They will give you a yearly interest rate. In big people terms, APR. Annual percentage rate. Means at the end of the year, that's the rate that they're calculating. But we're not just calculating it during that amount of time. We have this N involved. N is the number of times in a year. Because that does actually affect what you're going to end up with. And then we have T, which is your time in years. Okay? So we've only changed really quite a small thing here. We've broken up my rate over how many times I'm compounding per year. And so then I'm going to times the number of years times how many times that happens. So if I'm talking about monthly and I want to go over 3 years, 3 times 12, that'll happen 36 times. And instead of just the rate happening once per year, I'm going to break that up over monthly 12 times. So what we need to make sure that we understand is some of these terms. I'm going to give you the first one. Yes, sir. No, that's just how many times they compound it. So like for your credit card, and they compound your interest every month. And so if it happens every month, what is N? Yeah. If nothing else changes, and for this class, we're just going to stick with the no deposits, no withdrawals, no payments, no nothing. We're just looking at the very most basic form, because that just gets to be a real headache. Nobody wants to do that. All right, so if something happens once a year, do you know what that's called? Annually. I don't remember. 2 N's? We'll go with 2 N's. Annually. Does annually have 2 N's and 2 L's? Yeah, I teach math for a really good reason. Okay, we'll take one of those N's out just for giggles. I hate English. I love to read. I hate spelling, I should say. I teach math for a reason. I don't. Oh, look, annually, yay! And if it's written there, it's probably right because spell check will give me a little red under squiggly line there if something's wrong. This is why I prefer typing than handwriting. All right, if something happens twice a year, that's biannually. Bilaterally. Biannually. What does semi-annually mean? Not really, because that's almost annually. So almost annually means almost yearly. So does it happen yearly? No, it actually happens every 2 years. Does that make sense? Semi-annually means you only get some of it per year. You need another year to get it. So semi-annually, when we get to that one, we'll just go ahead and write that down now. N is 1/2, because you don't get a full one in a year. Mm-hmm. And then, so if you were looking for 2 years, how many times is that going to compound semi-annually? Just once. Just once. Because if it's semi-annually, it's going to take 2 years for you to get that full rate. Does that make sense? Okay. So what do you think I'm going to call it if N is 4? Quarterly. Good. Plays a huge term in businesses, your quarterly sales, your quarterly HOA dues. You must live in my neighborhood. If N is 12, what do you think that is? Oh, you guys are so smart. 12 is when we're talking about something happening monthly. What about 52? Weekly. And 365? Daily. And it's important that we can kind of understand those words because they're not going to come out and tell you N equals something. They're going to tell you that it's compounded quarterly or compounded annually, semi-annually, biannually. They're going to be using those words, so you need to be able to differentiate it that way. All right, so go ahead and read through this first problem for me, please. Okay, so if I'm looking at this problem, can you tell me what the 300 is? That's your principal. That's P. Okay. And it says 5%. What's that? That's your R. So what is R? 0.05. Is that a positive number or negative number? Positive, because we're gaining that kind of when you're investing, you get more. Whoops, that's all. Yes, that's a positive. That's a positive. And what you're going to see, I'm going to be saying this to you a lot. He makes no other deposits or withdrawals. That means I'm not complicating things. We're not saying, okay, every month he puts in $50, because that makes it a lot more difficult to kind of work out. Then it says find his account balance after 15 years. So what does that mean? T is 15, because your time is always going to be in years for this stuff. Where semi-annually means that N is 1/2. You might want to highlight that just so that you don't kind of forget that one. People confuse semi-annually and biannually very easily. So you just want to kind of be careful and be aware of that. And for monthly, what is N? 12, right. What we're going to do here is we're going to use this formula with these pieces. So for the annually, we'll say the amount, which is what I'm solving for, is the principal times 1 plus the rate over N, and I'm just going to do that as 0.5 because I think that's easier, to the N times T power. So go ahead and tuck that into your calculator. See what we got. What do you get? $613.15. And we're going to use that dollar symbol as the label. What I always think is just freaking hysterical is the number of people who will literally write out the word dollars at the end. I giggle. In America, we do that. In Europe, you do the euro. I don't even know what the pound symbol is. I don't know. Is that like something over something or? That's the euro. That's the euro. Yeah, whatever. Dollars. Awesome. S with a line through it. Yay. All right, can you guys calculate the monthly value? I want you guys to go ahead and calculate the monthly value for me, please. If I compound monthly, how is this going to be different? Is it going to be different? Okay, what you got? 6.34 Which one would you rather have, semi-annually or monthly? Monthly. And the reason why, because it's a bigger number than this one. We actually like the more often that you can compound when it's you getting money, the better. When you lose the money, we want it as rare as possible. Please don't ever apply interest. But when we're earning money, we like to compound because remember, every time you compound your interest, you get interest on the interest you already got. So the more often you do that, you see a little bit of a difference. Yeah, that's not that big of a difference, $300 over 15 years. But when you get older, that'll be $3,000, $4,000, $10,000, $30,000. That stuff grows like crazy. And these are things that you need to be aware of. So, let's try number 2. I want you guys to do number 2, and actually when you finish 2, go ahead and do number 3 as well. All right, let's take a look at these answers then. Number 2. So you have quarterly, where N is 4, daily, where N is 365. So far, so good? Questions on those? Okay. And number 3, bi-monthly means bi-monthly means it's going to occur 2 times a month. So that means 24 times a year. So that's why I have a 24 here and a 24 there. And a lot of jobs you get paid bi-monthly. So that kind of lines up with that. All right? I have one more formula I'm going to give you. And this is what happens when interest is compounded continuously. Now before, when we said continuous compounding, we said, what did we have? We said f of t was equal to a e to the rt. Remember doing that? All we're doing is changing our notation. So we're going to say the formula for this is that the final amount is equal to the principal times e to the rt. Also frequently referred to as PERT. Back in the day, PERT was actually a shampoo. It was like a 70s or something. I never used it. It was kind of before my time. Is it still a shampoo? They still have it? Cool. Green bottle, kind of simple. Soap. And that's PERT. So what means with this stuff is where we go from here, we literally back up and do what we did last class. So if I look at problem number 4, I have, let's see here, 800. 800 is my what? That's my principal. 6% is the interest rate. And compounded continuously means I'm going to be using E. 20 years is my T. Hey, I just get to set this up then. I just plug it all in. Say it says, how much will I have? What will my amount be if $800 compounds continuously at a rate of 0.06 for 20 years? Go ahead and calculate that. Keep it calculated. Anybody want to give me an answer? And make sure you put your dollar bills, y'all. So not a crazy jump in understanding, hopefully, just a little sidestep. I want you guys to try numbers 5 and 6, please. And hey, all we're doing is 9 problems total. Yay. All right, let's take a look at the answers here. So the straight up numbers for number 5 and 6. Did I do number 6 right? Yeah, I did. So I don't know about you, but for number 6, what option would you prefer? You sure about that? Why would you want A? Because it has more money. I'm being a smart aleck. I'm just really trying to throw you off a little bit. So yes, definitely go with A. And what's important to note, especially with problem number 6, is that a lot of times you will have options. Have you guys ever seen the commercials for NerdWallet? Do you know what I'm talking about? Some of us don't watch TV with commercials anymore because you guys are spoiled. NerdWallet is this place where you can go and they give you like based on your credit score, which does play a role in what your interest rates are, all of these different credit cards that you can have and what their different requirements are. And some credit cards actually charge you to use them. You must pay a $20 yearly fee. You must have at least this much money. You must pay off at least this much. And so you go look at a place like NerdWallet, and you'll see that you'll have some where you'll get an interest rate of, by the way, credit card interest rates are atrocious. They're usually in the double digits. And you can see which one is going to make the most sense for me. Okay, so if I have to pay 15% interest, but I get 2% cash back, you need to be able to compare these things so that you're making the right choice for yourself. Okay, and it's by doing what we're doing here. For me, when I bought my house, I got a 30-year fixed rate mortgage. A couple years later, the interest rates dropped, and I realized if I switched to a 15-year mortgage, I was paying more each month, about $200 more each month. But in the end, when I'm done paying off my mortgage, it's going to be the difference of like $100,000 in difference. Huge. And so you want to kind of think about these things. Yay, adulting. All right, so 7, 8, and 9. Stupid camera. Problem number 7. Some of you guys might even started doing this. That's great. Number 7, we are given different things. We have 500. What is that 500? That's your P. That's your principal. That's what you start with. Okay? Annual interest rate of 4%. What is that? R. That's your rate. And what you need to see here, that. Why is that important? The n equals 4. We have compounding quarterly. That's not continuously. That means I am going to be using n is equal to 4. And I want to figure out how long it will take to get me to 12,000. What's 12,000? A is 12,000. Or 1,200. So for this guy, because it says compounded quarterly and not compounded continuously, we will say the amount, my final amount, is equal to the principal times 1 plus the ratio divided by the number of times it gets compounded, and then that number again times the time. And we're looking for the time here. How do I solve this problem? Divide by 500. And you know what? I'm just going to kind of leave that as a simplified fraction. So I'm just going to say 12 over 5 is equal to, and can you actually do this piece? Can you tell me what that's going to be equal to? Okay, so the whole thing is going to be 1.01 to the 4t. How do I solve a problem like that? ln that sucker. And in doing so, I get to move that 4t out in front. And if I have that, what do I need to do to solve it? Divide by ln of 1.01 and 4. Now I want everybody to plug that into your calculator. That's something that's a little bit tricky. We want to make sure everybody gets to the same page with that. So what do you get for t? Yeah, 21.996, which is basically how many years? 22 years. Please, 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 guys, make sure you got that answer, because it is very simple to make either parentheses mistakes or just simple errors in entering this into your calculator. Is everybody able to get pretty much 22? Okay. Go ahead and read number 8. Yes, sir. Look how much time we have left and where we are. This is wonderful. So can you tell me on number 8 what formula I'm going to use? Am I going to use the formula with an n or a part? I'm going to use the part because interest compounds continuously. So it means I'm going to have the e. 500 is my principal, p. I said after 15 years, but I don't know what the rate is. The account balance had tripled. So what is my final amount? 1,500. I want you guys to solve that equation. Solve it like a rock star. Solve it. This is probably the most important application of logs and exponents most of you guys will deal with. This is a really important skill because sometimes it's like, well, I have to have this amount of money by this time. I'm saving up for college. I have this amount of years for stuff to compound. What needs to happen in order to get there? Do any of your grandparents or parents buy you savings bonds? Does anybody do that anymore? My grandparents used to get us savings bonds. It was the old thing that they used to do. Basically, you're borrowing money you're giving the government your money ahead of time, and then you get interest on it. And so we would get $50 savings bonds every Christmas and birthday. And then when you graduate from high school, you take all those savings bonds into the bank and you cash them in. And those $50 ends up getting interest and interest and interest. And so hopefully you have enough to pay for at least one semester of college by the time you get there. Not as popular anymore. Used to be. All right, so what did you get for your interest rate? 7.3% or 0.073. I don't care which one you want to use. All right, do number 9. Do number 9 and we're done. Check your answer with your neighbor. Wake up, little Susie, wake up. All right, ready to take a look at the answer? Yarp? Yeah? Let's see what we get. I got a little excited because I have people who are dorks and would do this to me on a test. Because I didn't specify how long, what unit. So it would take either 2.975 years, if you wanted to be crazy, 35.703 months, or really irritating, 1,085.96 days. Just because you can. Yes, I have had people do this to me on tests and quizzes. They think they're funny. Looks aren't everything. You do that, I will know. I will know. All right. How are we doing with this stuff? Okay, guess what your homework is? The back of the worksheet. There is one correction I need to make. So if you flip to the back of your worksheet and look at problem number 7. Number 7's got an oops in it. It gives you an interest rate and then it asks you to find the interest rate. And the interest rate it gives you doesn't work. So what I want you to do on number 7 is where it says that earns, cross out that interest rate because that is not the number. So it just earns interest compounded continuously. Does that make sense? Just scribble out that number and then everything falls into place. So next class, what we're going to be doing is I'm going to be giving you your review. Next class is going to be on Monday, which means on Wednesday is going to be your test. Okay?